Okay, so we're working on optimization, right? So up till now, we've had very basic problems where the equations that we're going to be using are based on either the shape or um, area or volume. Okay, but now we're going to have to come up with our own equation. Okay, so it says your dream of becoming a hamster breeder has finally come true. You are constructing a set of rectangular pens in which to breed your furry friends. The overall area you're working with is 60 square feet, and you want to divide the area up into 6 pens of equal size as shown below. The cost of the outside fencing is $10 a foot, where the inside fencing costs $5 a foot. You wish to minimize the cost of your fencing. So we need to find the dimensions that are going to minimize that cost, and then find the total cost of the pen. Okay? So this is very real world. Okay, because obviously if you're breeding hamsters and they're going to be outside, you want the outside fencing to be more sturdy than the fencing dividing the hamsters, because you're less worried about hamsters getting from pen to pen inside than something getting in and getting your hamsters or them getting out. So we actually have to come up with our own equation here. Okay, for cost, it's not an easy, super simple, but the equation we're going to be using does come from sort of a perimeter standpoint, okay? Because our cost comes from the perimeter and the inside fencing. So to keep things simple, okay, I'm going to say that these distances from here to here are x. So I got x, 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 right? I'm going to say these distances are y's. So my horizontal is, or x distances, okay? So looking at it in this way, what I'm going to do is I'm going to create what I'm trying to maximize. My primary equation, I'm trying to optimize, I'm actually trying to minimize it, is the cost, okay? So that is my primary, is my cost equation. Well, my cost is going to be equal to the fencing, right, that I'm using. So the big cost is going to come from the outside fencing, right? So that cost is $10, okay, times the amount of fence I need to do the outside, right? So if I add up, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x's plus 2 y's worth of outside fencing. Okay? Then I add the interior pieces, which are $5 times I have 1, 2, 3, 4, 5 Y pieces that are the inside fencing. Okay? So that is my cost equation. Okay? And now, that's my primary equation. What's my secondary equation? What's my limiting factor? What is it that I have to my constraint? The area. I only have 60 square feet. So my secondary is my area, which is in this case, well, yep, 60 feet has to be equal to what? The area is my length times width. So it's y times 6x. Okay? So let's simplify our cost equation a little bit. So cost is going to be equal to 120x plus 20y plus 25y, which means my cost equation is 120x plus 45y. Now, like our other optimization problems that we've done, we're now going to get our cost, our optimization equation into one variable by plugging in my secondary equation. So my secondary equation, I'm going to solve for y. So y equals 10 over x. Because you divide both sides by the 6x to get y by itself, and 60 divided by 6 is 10, so that's what I'm going to use to plug in for my cost equation. So I'm going to plug this y in here for that one, which gives me my new cost equation all in terms of one variable. So cost is 120x plus 450 over x. Now we're going to optimize it. And to optimize it, we take the derivative to find our critical points. So cost prime is 120 minus 450 over x squared, and then we set it equal to 0. That means 120 equals 450 over x squared. So I moved the negative 450 over x squared over. Cross multiply, so you get 120 x squared equals 450. So then you get x squared equals 450 over 120, like that. Then we reduce, which gives me x squared equals 15 over 12 divided, because that's 3, 12 divided by 3 is 4, like that. So x equals the square root of 15 over 4, or the square root of 15 over 2, which is approximately 1.936. Okay. So that's my x, right? Then they say we need to find our dimensions, so we need to find y. So that's 10 over the square root of 15 over 2, which is dividing by a fraction is the same thing as multiplying by its reciprocal. So that'd be 20 over the square root of 15, which is approximately 5.16397, which makes sense. We'd want to use more of the middle of the, because it uses more of the less costing material than the more costing material. So those are my dimensions. Well, of course, this one would be, this is x. So if you need our total dimensions, you're going to multiply that by 6. So it's y this way and the whole side, or if you're talking just for one pen, that's the x value for one pen. Now, we're not done yet, because part B says to find the cost. So part B, that was part A. So part B, we need to find the cost. And the cost is equal to, if we go back to our equation right here, that's 120x plus 45y, which means it's 120 times the 15 over 2 plus 45 times 20 over the square root of 15, which is approximately, cost approximately $464.76. So using a calculator, now notice that the total X piece and the total Y piece ends up being the same amount of money. And my total amount is $464. So when you throw in this cost part of it, we've been dealing with areas and volumes and things like that, and you've been noticing the dimensions are relatively constant, where we're dealing with figures that turn out to be in a more of a square shape. Like when we do areas, squares tend to maximize and minimize area. Same thing with volumes. When we did a rectangular prism, ends up being more of like a cube, or a rectangle that's exactly twice as long as it is tall. So those kinds of things you'll see. And even here, when we see our costs for the X component and our costs for the Y component are exactly the same. So we see a lot of this happen in our optimization. So just remember, you're finding your primary, you're finding your secondary, you're using your secondary to limit our primary and get it in terms of one variable, take the derivative, set it equal to 0, and then answer the question that they've given us.